I'm Leah Laney, Sales Manager of Advantageous Solutions. Welcome all. Thank you for joining us on this webinar for UniForce in depth. The presentations should last about 30 to 40 minutes, and then we will address the questions. Matt Hagney is the president of Advantageous Solutions, and he will now present UniForce in depth.
Thanks, Leah. Yeah, first and foremost, I was an agronomist. I got into equipment in sort of a roundabout way. For those who don't know my history, my passion's always been making no-till more profitable, since it's really the only sustainable system we have for farming. And in working on the agronomy for no-till, I quickly became aware in the mid-90s that the seeding equipment wasn't working very well. So I started dabbling in that, and one thing led to another, and 20 years later, here we are. So first I'm going to talk a little bit about why you might want UniForce before we delve into the technical details, so that you have a complete understanding of the advantages. The main reason that the UniForce is such an advantage over the springs is that when you have a parallel link that are pressured by springs, there's not that much difference between the bottom end of the stroke versus the midpoint versus the top end of the stroke and the parallel link. Oh, there might be 20–30% difference in spring pressure between the low point and the high point, but it doesn't drop off dramatically like it does on the swing arm. So getting rid of the springs on this swing arm design is vastly more important than getting rid of springs on parallel links like we have on planters. Here's what we're talking about with the swing arm design. This rock shaft rotates to lower the openers into the soil and provides pressure onto those openers by compressing that spring there. So it's all rotating around the single pivot point, and that's why we call it a swing arm. The arm is moving rather than this whole thing being on a parallel link. So when this is moving, rotating up and down to follow the contours or rattling by not having enough pressure on it, all these angles change, particularly the seed tube, the seed boot, and its relation to the soil. And that affects performance a lot. On the planters, if you've caught any of my presentations or read my comments on planters, we want the seed tube to be as vertical as possible and dropping the seeds way up here, right at the deepest point where the blade cuts. That's where you're most likely to get the seeds to the bottom of the furrow before the sidewall and dust and duff start falling in ahead of the seed. And if that dust and duff is dry, you're going to have seeds in dry soil rather than the moist furrow bottom. Not to mention your depth control is going to be erratic. So on these deer drills, the internal channel of the seed boot is already at a very undesirable angle. It's 45 degrees this way, so the seeds are ending up way back here, which is 4 or 5 degrees or more, 4 or 5 inches or more past the deepest point where the blade cut. And we know from working on planters, every inch rearward is just that much worse for seed placement. That's why we're so adamant that planters need to be ran a little bit nose up to get that seed tube as vertical as possible on planters and be dropping the seed up closer to where the blades have cut at the deepest spot. So on these, when you're going down through a depression, we get a little more vertical. That's a good thing. That's also why being slightly over-rotated is not such a bad thing on these drills. On the flip side, when you're a little under-rotated, Now that trajectory of the seed is even flatter. The seeds are even more likely to ricochet out of the furrow. They're dropping a lot farther back from where the blade is cut, and the placement's just really bad. And also you can imagine, well, if you don't have enough down pressure on this opener and it bounces up a little bit from where it's supposed to be, well, obviously not, the blade isn't cutting as deep as it should, but even worse, your seed trajectory has gotten flatter and seeds are flying out everywhere, sidewalls caving in, dust is falling in. Seed placement's really lousy every time this opener bounces or skates out a little bit. And that's why to make this drill work decently at all, we really crank the pressure up at times, and that creates other issues. So with the springs, all we're doing is we got to compress that. By rotating this rock shaft, usually we have it sloped down in the rear a bit to get this compression. And when things are going well in long-term no-till, we need 2 to 3 inches of compression on this spring to make it work right, to hold that in the furrow. What it says on the gauge is really somewhat irrelevant, and where this rock shaft is doesn't tell the story either, because the drill frame might be lifting. The only thing that's really important is how much compression of this spring you've got. And because there's a rod and a bolt that hold this together, you can kind of stick your head down in here and get your eye on this, and you can see how much of that rod is sticking out of the casting below. And you'll go along and you'll see, well, they're different. You thought the field was pretty level there, but in one spot you might have very little rod sticking out below that spring. Here was your optimum 2 inches, and here it's on a slight mound, it's up to 3. So what's happening there? Well, since that spring's only compressed 2 inches at optimum, if the opener falls down in a 2-inch depression, now that spring rate is 0. You've lost all the pressure. And so to compensate for that, we crank the pressure way up on all these other openers just to get the last few to sort of do something that's somewhat acceptable. But they're losing pressure, they're not maintaining depth, they're hairpinning terribly, and like I said, that trajectory of the seed is more out on top of the ground versus down in the furrow when you're like this and the boot's riding up. So really then it's a failure of that spring mechanism and the way it's oriented on a swing arm design. It's just really hard to make that swing arm design have any semblance of consistent pressure the way that spring is oriented on there. And note that you've got all kinds of depressions out in your field. They're called combine and sprayer tracks. And you might think, wow, I didn't throw any soil out of the furrow, it wasn't sloppy mud. But just lay a straight edge across where that track is, and you'll see it's depressed, even though it didn't throw mud out of the furrow. It squished the soil down. Might be an inch, might be more than that. So just when you needed maximum pressure to cut into that combine or sprayer track, now you've got half or none because that spring is relaxed a little bit. So I've long known this was a problem, and we just crank the depth up. But it's not just poor depth control, poor depth of cut in those, but it's more misplaced seeds because the gauge wheel isn't firmly on the soil surface in this. The gauge wheel's above the soil line, or it's just lightly touching. So it's not doing a good job of keeping the sidewall out of the furrow. The trajectory of the seed might be improper, and the seed boot is above the soil line if that is occurring. And somewhere in here I had a photo. No, never mind. So again, we're trying to reach down in there, and it's not doing what we want. because the bottom edge of the boot isn't even on the soil line anymore when you've got this happening here. The boot here would be right on the soil line, skimming the soil surface. Here there's a gap. The boot's way up here, bottom edge, so you've got this big gap. So not only are we not holding the sidewall together with the gauge wheel, we've now got this huge gap for seeds to escape. Even more so than with planters, the only thing guiding seed into the position is the furrow sidewall. And so we've got to hold that sidewall together as much as we can. That's why we need the gauge wheel firmly on the soil surface with adequate downforce. We want the gauge wheel located properly fore aft, which the deer drill does a good job of that. It's in the right spot. We don't want RID gauge tires, the indented ones. And we prefer narrow gauge wheels because we've got a little more, the gauge wheel's tilted away from the furrow because the blade is. And using a narrow gauge wheel, we can move that holding power closer to the gauge wheel and do a better job of controlling the sidewall blowout. And also we're not trampling so much stubble with the narrow gauge wheels. So here's what happens in cross section. If your gauge wheel isn't firmly on the soil surface, or if you've got an RID gauge tire, you're letting this lift because the blade's pushing soil this direction and the soil's wanting to adhere to that blade and follow the blade as it rotates up out of the furrow. It's pulling it up, so you get these crevices here. Seeds bounce over into those if the soil's kind of tacky. And even worse, the sidewall is blowing apart and it's crumbling in and falling in ahead of the seed. And then we've got seeds that are not only shallow, but they might be in dry soil. So all of those things, here's the photo I was looking for. The bottom of your boot is, depending on how much wear you've got up here in your attachment point, in the middle hole, it's about 1 3/4 inches from the bottom of the blade with a new 18-inch blade on there. If you've got some wear up in the attachment hole, this drags farther and farther out, and it creates more issue. This boot was in pretty good condition. We're seeding, well, just shy of 2 inches deep here. You can see the lower edge of the boot is horizontal with the soil line. No gap there. But these seed bounce flaps have a gap, and seeds bounce out of that. And if your opener is bouncing, you don't have enough pressure on it, it's fluttering upward, you're getting a triangular gap here under the boot, and this triangle gets a lot bigger. So there's a lot more room for seeds to escape. You can see in this case, this boot is a little bit above the soil line. This opener didn't have quite enough pressure on it. And so there's a gap here that can cause problems. So there's numerous factors beyond just not cutting the furrow to the proper depth. You're getting a lot of misplaced seeds with the OEM spring downforce. So to make it decent, we crank the pressure way up and we add a lot of frame weight. So I've long known this was a problem, and a number of years ago I got the idea, well, we've got airbags and hydraulic cylinders on planters, maybe we should get rid of this silly spring on the deer drills and accomplish not only the same thing, but actually quite a bit more. So it took me a little while to get myself psyched up to do this, and we got it done. We can apply far more downforce with the UniForce, up to 700 or 800 pounds, versus 400 pounds with the OEM spring on a Deere 50, 60, 90. The 2510H actually has more spring pressure. They need it because they're a larger blade and trying to hold all that in the ground. And the spring is the wire size is a larger diameter. I think it's 5/8 versus 1/2 inch or something like that. So it's applying more pressure, but we can exceed even what the springs do on the 2510H. And yet UniForce is far more gentle when on those other openers. We can back the pressure way off. We can get it down to where it's just the weight of the opener, just like the Deere spring. And instead of over compressing 3/4 of the openers with the springs to try to get the last few to work halfway decent, now we have the same pressure on every single opener, no matter where it is in its stroke. If you want 500 pounds of pressure, you've got it set accordingly. We've got 500 pounds of pressure down to the very last bit of stroke, and we've still got 500 pounds if the opener is way up here at the top end of the stroke. Not only that, we've added a little more than an inch of downstroke and several inches more upstroke. So we've got way more up-down travel, and when going through those depressions, we've got not only 1 inch more of total downstroke, but we're effective to the very last bit. So we've got about 3 inches more of effective downstroke than what the springs have. And this is a tremendous advantage, not only going over terraces, but just dealing with all those combine and sprayer tracks in the field, as well as just mild undulations from old disc ridges and some rills that are formed, whatever. Some of the other benefits: reduced wear on the main pins and bushings because the opener isn't fluttering going through the field all the time. It's riding nice and smooth now. Less wear on the depth adjustment. Those things aren't rattling anymore. Now this is, of course, predicated on you setting the UniForce high enough that those openers run smoothly. But if they're set properly, we eliminate all this rattling around. Because we're running smoothly and there's no bounce like you get with a spring, we can operate faster with the same ballast, or you can take some of the ballast off. And we've greatly reduced the sidewall compaction because the opener never exceeds what you have it set at. And if you've been around these drills much in damp soils, or even soils that are in nice condition, you realize that there's a tremendous amount of compaction going on with these drills. So we started developing this in 2015, marketed in 2016. So this is actually the 3rd year on the market. It's proven. We've really done very little to change it. We're just really happy with everything we're seeing. Okay, some of the technical aspects. UniForce uses 4 to 8 gallons per minute. It's actually low enough that it's kind of hard to get a good reading, even with an expensive flow meter. It runs about 8 gallons per minute when you're first pressuring it up, and then thereafter it's running about 4, unless you dump a lot of oil. Contrast this with an air cart fan that uses 25 gallons per minute. So we are adding some, but it's not a huge amount in relation to that. But if your tractor is an older one that's already maxed out, just running that cart fan, you're not going to be able to run UniForce. And we were messing around with the tractor. I think it was like a Deere 8760 or 8960, one of those. And it could just barely run the air cart fan and was not capable of running UniForce in addition to the cart fan. So in some cases, you got to have a new enough tractor to be able to handle that if you're running an air cart and blowing a lot of product. That was worst case scenario, blowing fertilizer and wheat seed. So 250 pounds of product per acre at 7 or 8 miles an hour, it just couldn't handle it all. CCS fans don't take nearly as much as an air cart fan. You're not blowing near as much product, not blowing it as far, not as many runs. And if you're a box drill, of course, you don't have much issue at all. But if you're running 30 or 40-year-old tractors on some of those, well, it might still be an issue. But you can look up the specs on the pump on your tractor, how many gallons per minute you've got, and do a little calculation. If you've got, even on an air cart, a drill with an air cart, if you've got 35 gallons per minute, you're comfortable running UniForce, no problem. Even 30 probably would get it done, unless it's a huge air card. CCS fans, you can get by with a lot less. If you have questions, just call us and we'll try to give you guidance. The last thing we would want to do is sell you a UniForce system that your tractor couldn't handle. Do you need an extra remote? Well, we like to have an extra remote. We like to keep the UniForce separate from the rock shaft, but we can run them all on the same remote if need be. The exception is if you're using Power Beyond for your air drill, we absolutely have to have a separate remote for UniForce. And that's because Power Beyond is only running intermittent flow to run, say, your meter rolls or your rock shaft. It's just a little trickle on demand now and then, boosting it. UniForce needs continuous flow to work properly. So we need to keep it separate from the Power Beyond setup. So in that case, you might need to add an extra remote on your tractor. The downside of running everything on the same remote is that when you lift the rock shaft, because of backfeed through the cartridges on our manifold, the pressure on the UniForce spikes to the maximum that the tractor has for output, 2,700, 3,000, whatever that is. Now that's no problem whatsoever for wear on the system. There is no wear because nothing's moving. It does create a little more issue for getting all the leaks stopped when you're running at 2,700 PSI versus 1,400. But otherwise, it's not much of a concern. Also, you can't run the in-cab adjustment mechanism if you're trying to run everything off the same remote, because that motorized control valve won't handle that back pressure. It locks up and won't adjust. So how many remotes are you operating each time you turn on the headlamp? Just one, just the OEM rock shaft. The UniForce stays powered up the entire time, even in transport. Indeed, it needs to stay powered up in transport on air drills, or those openers are flopping around all over and causing damage. So we run it pressured up all the time unless we're servicing something, then we put it in float. How do you set the down pressure? Well, you are only setting one thing, the UniForce. We set the OEM rock shaft at a very high level and forget about it. We never adjust it again. Its only function now is to raise and lower the cylinders, and we want it to overcome the UniForce cylinder pressure to quickly get the rock shaft rotated fully into the down position, twisting it as far over as it'll go. What you're running for pressure here has no effect on the pressure of the openers. You run this at 2,000 PSI, take all the pressure off the UniForce, and it's just the weight of the opener there. It's only the UniForce system that is determining pressure on the openers at this point. So we set this way high and forget about it. So the downforce is with the UniForce knob and gauge. We usually run 800 to 1,500 PSI on that. In many ways, UniForce is a fairly simple system. There's no electronics on it unless you opt for the in-cab adjustment that has a motorized control valve that replaces the knob. So we're just supplying a lot of oil. The pressure is constant by being able to move around. It's a very rugged system. These are not your ordinary cylinders. These are special built with extra pack rings. Everything on this system is overbuilt with high quality components for many, many years of trouble-free service. We don't have any way to measure the downforce applied to the openers, although we hope to have that in the near future. As to controlling each opener individually, that's going to be extremely costly, but someday we might offer it if we can do it somewhat affordably. Basically, it would at least double the cost of the system and maybe quadruple or quintuple the cost of the system. And Not too many people are going to go for that, I'm afraid, and justifiably. So here's what our control valve block looks like on a box drill, or if you had a CCS that was just a single rank, like they have in the Corn Belt, the ones that are just, they do 15-inch, and that's all they do, only one rank to them. This will handle 15 gallons per minute, so it'll handle 34, 36 openers pretty easily. Not a problem restricting the flow on that. And so you just adjust the pressure that you're wanting on the openers with this knob, got a readout in this gauge. When we're controlling more than 36 openers, we go to our Big Daddy valve block manifold here. Each cartridge that goes in here will handle 12 gallons per minute, or about 26, 28 openers, something like that. Probably a little more than that if you're not in terraced fields. And there's some cavity plugs over here that we can keep installing cartridges and run up to 100 openers. So behind each cartridge, we've got hoses, big 3/4-inch hoses coming back here. Tee them all together, and then run them on back to each rank. We plug in an accumulator into this if we have one. 3/4-inch lines going to the tractor. Most of the time, there's just a trickle of oil going through here. But if we need a lot of oil in a hurry, that's why we've got these big lines. And on this valve block, it's just this knob here, adjusts your pressure on this gauge. Pretty simple. Here's looking down from on top of that valve block. This is on a 60-foot drill on 10-inch spacings. So it's got, I don't know, I think 68 or 72 openers. So it's got 3 cartridges installed here. Here's the empty slot here. And there's 3 of these feeder hoses coming back to handle the oil from behind each of those cartridges. These are all teed together. Then we've got 4 hoses going back, delivering to various places on the air drill. We've got a big accumulator over here plugged in there, and the 3/4-inch hoses going to the tractor. Here's the OEM valve over here. All it does is run the rock shaft. Why an accumulator? Because no matter how big the hydraulic pump is on the tractor, the flow through the remote is limited to 25 gallons per minute on most any of these 1/2-inch remotes. I don't know of any exception to that. That's only 0.4 gallons per second. At 8 miles per hour, you've covered almost 12 feet in that time. So that's much too slow if you've collapsed and dumped a lot of oil. Collapsed a bunch of cylinders by going square over a terrace or big berm. You've gotten rid of a couple gallons of oil at that point, and it would take several seconds to replenish that just from the tractor pump. So you'd have less than desirable pressure for 30 feet in the field after going square over that terrace. So this 2.5 gallon accumulator applies about 1.5 gallons in a fraction of a second. It's almost immediate. So it does a lot to overcome that. Now, if you don't have terraces, you definitely don't need an accumulator unless you've got some other speed bumps in your field that resemble terraces, drainage ditches or things like that. And even then, it really only comes into play if you're going square over them. If you go at an angle, it really doesn't matter. And also on a tractor that had relatively low pump capacity in relation to the number of openers, you might benefit from an accumulator. Can you omit the accumulator if you have terraces? Yes, we've got people that do this. It's, even if you've got miles and miles of terraces out in the field, how often do you go square over them? Not that often. When you hit them at an angle, it's really not an issue. And it's a much bigger factor if you're only using 1 rank versus 2, because we have these cross flow hoses between the ranks on 2-rank air drills. I'll show you a diagram of that in a minute. But when you're going over the berm of a terrace, the front rank hits the berm, and it's collapsing all those cylinders. Well, where's the back rank at that point? Well, it's down in the valley at that point. So the front rank cylinders are collapsing. At the same time, the rear rank is extending all the way. So a fair amount of oil just dumps from the front rank to the rear rank rather than going back through the tractor. And that's a good thing. So it's even doing better than an accumulator by having that feature. Here's what I'm talking about with cross flow hoses. Just a quick sketch of what we're doing on a 60-foot 5-section drill. Here's the front rank. Here's the rear rank. These are our cross flow hoses. These are big 3/4 inch hoses out on the ends and another one in the middle, so that when these openers are collapsing, if these are extending, we can just dump oil back here very quickly. Here's your manifold. These were the 4 feeder hoses that go back out here. We try to get them out on the wings away so that we have a lot of paths for the oil to flow quickly and readily. If you go at an angle over the terrace and these are collapsing and these are extending, we can not only shove oil through here, we can shove it through here, we can shove it all the way back here and over here, we can shove it back through. Remember, these are all connected here, so it doesn't have to go through the manifold. We can shove it back through here, and down here. And all these hoses are swelling as that oil surges. Those hoses swell about 30% under pressure, so that does a lot to mitigate those pressure surges and get the oil moved around to where it needs to go. And some of that surge is going up here into the accumulator, and the last resort is it goes back to the tractor. We hate to send it back to the tractor because it takes a while to get it back. Here's another shot of that accumulator on a 5-section drill. Here's our center tray that supports that header hose, and then we've got drop hoses coming down to each cylinder off of that. On a box drill, we use 1-gallon accumulators, and if you've got a box drill pulled on 2 of them pulled together on a hitch, we put 1 accumulator on each drill, so the oil's right there where the drill needs it quickly. This is just kind of showing how we lay this out. This is a 5-section drill, 60-footer. We've got trays on the front rank to support these header hoses. All this stuff is powder coated, so it'll look nice for a long time. We try to get all these hoses routed so it looks like a factory install, basically. This isn't quite the finished product here. We've got some nylon woven hose protectors that go over these so that when you have corn stalks, sunflower stalks, striking these, it won't eventually wear away that protective sheath on the hose. Here are the drop hoses going down to the cylinders. Here's this big feeder hose coming from the manifold to the front rank, inner wing, outer wings back over here. Here's the feeder hose to the rear rank. Here's that protective cover. Here's the outer wing on a 5-section. And here's that cross flow hose. Here's a 3-section drill. This happens to be an 1895. So it's got this extra rank up here with mid-row banders for fertilizer only. We only put UniForce on the seed openers, these 2 rear ranks. Again, here's the trays and the drop hoses. And there's these there's a hose that bridges between each of these sections here, like that. On box drills, it's a 1/2 inch that we're using for a header hose. This is the front rank. Again, pretty clean install, got everything. This is all very well protected by the rock shaft, and the openers are rotated down into position, so we're not going to lose any hoses to tree branches or abrasion or anything like that. Here's the rear rank. We do have kind of a more traditional header hose and drop hose configuration here. on these, and we attach that header hose with these big 1/2-inch bands every couple feet across the drill. It's pretty secure. Oil heating. Yeah, because you're running an extra 4 gallons per minute through there, there can be some heating. It's, you know, higher pressure, so there can be some additional heating. It's really only an issue for the largest drills in really high temperatures, and usually you kind of know because those drills are borderline overheating the hydraulic oil anyway. You add UniForce and now you've got to take some extra measures. So what do we do to keep things cool? Well, the very first thing you should do, even if you don't have UniForce on an air drill, you should run the fan return into a low pressure port. This will keep your oil cooler. The fan motor will last longer. The hydraulic fluid lasts longer. The pump on the tractor lasts longer. Everything lasts longer by keeping it cool. So that's your first step. If it's one of these modern tractors that you bought the double pump option, the remotes are dedicated to each pump. For instance, remotes 1 and 2 will go to one pump, remotes 2 and 4 will go to the other pump. You should configure things so that the one pump handles the high flow, low pressure task, like the fan. It's got huge 25 gallon per minute flow, but you usually only run like 500 PSI through that. The other pump should do the low flow, high pressure task, like UniForce or the rock shaft. We're running, 1,000 to 2,000 PSI, but we're only running a few gallons per minute through there. If you try to run both high flow and high pressure with the same pump, you add a lot of heating. So splitting those tasks keeps your oil a lot cooler. This is can be a pretty handy trick on those tractors that have double pumps. If you still can't solve your overheating any other way, install a heat exchanger. Actually, a lot of people that don't run UniForce like these heat exchangers because you're warming and drying the air going through the air lines of your drill, and that cuts down on the gunk accumulation and keeps the dew out of there and keeps the lines clean. Very few UniForce customers actually have to add this heat exchanger. It's really the ones that were running in high temperatures like Kansas and southward in summer or early fall, moving a lot of product, and everything gets really, really warm. Particularly the 5-section drills run in 100-degree temps. It's tough to keep everything cool even without a UniForce system. And part of that is fan return and things like that. How long does it take to install a UniForce? 3-section air drill with 48 openers, 25 to 30 hours if you move along. Box drills are faster because you don't have all those trays to deal with. 5-section air drills, actually, it's a slightly faster per opener because you don't have trays on the wings on the rear. We just tie it to some existing hose trellis that's there. So that gives you an idea of what your install time is. You should add another hour or two to get the air purged. But allow a little extra time in case you run into something, obviously. Don't attempt this 3 days before you're going to the field. Follow the instructions carefully on purging the air, and it's pretty easy to do. Along with the instructions, you get schematics that show you these header hoses for all the different drill makes and models. It'll show you exactly which fittings you should be using to accomplish this. This is the left front wing, and you've got different lengths of header hoses, and those are spec'd in inches here. It tells you the length of drop hoses. There's a cover sheet that tells you what length L pertains to in medium. This tells you if the fitting going into the cylinder sometimes needs to be a 90 to clear the framework, like an opener will be right underneath a frame tube. So you'll need a 90 to get that drop hose to escape out from under that frame tube. So we try to make this as easy for you as possible. What about if you want to run more pressure in the tractor or air cart tracks? Well, we can handle that pretty easily. It really only makes sense for controlled traffic. The reason being is that almost always there's going to be harder tracks somewhere else out there, your sprayer or your combine. You need to crank the pressure up to handle those. What your tractor and air cart are freshly creating usually aren't near as bad as the old combine tracks and sprayer tracks that have been baked out hard and dry, and usually the pressure is higher, and those are just worse tracks to deal with anyway. But if you're doing controlled traffic, or you just flat out want to run more pressure in the tractor and air cart tracks, we just run a sub-circuit to control those openers separately. If you've got one of our large valve blocks manifold that doesn't have all 4 cartridges installed, we just sell you a different cartridge that controls those other openers in the wheel tracks. Put a gauge on top, route your hoses, and you're good to go. This cartridge has a set screw in it that dictates how much pressure is added. So you can never run less pressure in the tracks, which you never want to anyway. But you could set this at, say, 200 pounds more. So then whenever you adjust your main knob on the manifold, it automatically adjusts the ones in the opener tracks to be 200 pounds more or 400 pounds, whatever you have the screw set at. If you're using one of the smaller valve blocks, then you need to add another one of those. So you've got 2 knobs to adjust to control the majority of the openers versus the ones in the wheel tracks. I talked a little bit about some of the things going on with these drills in terms of seed flaps, angle of operation, seed boots, all those things. If you want more information on that, we did another webinar that you can find. Just Google for this. It's by No-Till Farmer, hosted by No-Till Farmer, and it covers a lot of stuff, quite a lot in an hour. If you want even more detail, we've got DVDs and a ton of information in our newsletters. We've also got some info on YouTube, including a video of how to install these the hydraulic cylinders on these openers. Not that it's all that complicated, but we just did a quick video to help you along if you want to view that. So with that, I'll turn it over to questions. Or on the planting speed, you can run pretty easily 1 or 2 miles per hour faster than you could with springs and still do a much better job with the same ballast. Basically, you can keep increasing your ground speed until it's just too rough or you don't have enough ballast to hold the drill in the ground anymore.
Okay, Matt, another question was if you can decrease your seeding rate.
I don't know that you can decrease your seeding rate much. Certainly you're doing a little better job and you'll have fewer thin spots in the stand. And every time that opener is bouncing, seeds aren't being placed correctly and you'll have a gap in the stand. Every time that opener doesn't penetrate because there's a slight depression, you'll have a thin spot in the stand. So we're getting rid of all those thin spots, which helps tremendously for weed control. But as far as decreasing seeding rate, I would be skeptical. I wouldn't want to make any statements about that.
How does the end of row sequence work?
Okay, so when you get to your headland and you want to lift up and turn, the UniForce stays powered up. You never touch that unless you're, regardless, you never touch that lever. You keep that locked down all the time. So the only thing you're toggling is your rock shaft up and down. That's the only thing that happens on your turn rows.
as for now, that's as many questions as we've received. We did get one that asked if this will cut the trash better, which I did address while you were off, but you can go ahead and address it as well.
Yeah, this cuts down on hairpinning dramatically because you've always got full pressure on those openers all the time. So we see much better cutting of residue with UniForce and just much better seed placement in general. Get rid of all those thin spots in the stand, assuming everything else on the opener is working correctly.
Are there any studies to show comparing yields with the springs versus the UniForce cylinders?
No, we don't have any yield data.
Anyone else have any questions? You can type them in on the side.
And of course, we're available to answer questions directly. Call us or email us with the contact info on your screen. I guess if there's no further questions, we might as well sign off.
Matt, I'm getting a few more here.
Okay.
I see one. Is the lift height on the openers lower?
Yes, in transport position, our openers hang about an inch lower than with the OEM springs.
What kind of make of the hydraulic hoses are used?
We use Gates hoses, I believe. That might not be correct. I'm not sure what brand. They're high quality. They're rated to 3,000 PSI. We use all high quality fittings. We've got the person doing the crimping is very skilled, so we almost never have a leaky hose.
What cost are we looking at, and is financing available?
Say a 3-section drill, 48 openers on an air drill, you're looking at about 20,000, give or take, depending on whether you need an accumulator or not. We do have financing available, or there's a 6.5% cash discount.
And it is best to either email ourselves at Exapta email or call in to get exact pricing, because it can vary quite a bit on pricing depending on the width and spacing and if you need an accumulator.
Yeah. I think a 24 opener box drill is around 9,000. 72 opener 5-section air drill is around 30,000, I think. getting back to how low do the openers hang, that's on the 60 or 90 that ours hang about an inch lower. On the 50 series, ours don't hang any lower. But those already had less clearance in transport on the 750s. The 1850s also, if they had the drop kit.
If you have stones in your farming system, how hard is that on the openers?
If you have, I didn't understand. If you have what?
If you have stones while using UniForce system, how hard is that on your openers?
UniForce isn't going to cause any more opener damage than the springs do when going over rocks.
So when
Possibly
the opener,
less.
okay, so when the
Probably
opener
less.
hits, okay. So when one opener hits a big rock and there's no cutting through it, will that one opener have some give in it and the rest of the openers will not be affected?
Correct. We've got a big 1/2-inch hose coming out of that cylinder, so it can dump a lot of oil in a hurry when it needs to climb up over a rock. And just to be clear, these are single action cylinders.
It looks like that might be all of the questions so far, Matt.
Okay. Thanks for attending, everyone.
Yes, thank you. And if you do have questions, please feel free to email us or you can call us at 785-820-8000. And there is a recording that we will post on YouTube eventually, or we could email you the recording as well.